Alright guys, last section of this unit, section 5.6, sequences. Okay, so sequences. A sequence is a list of numbers that follow some rule or pattern. Okay, a number in the list are called terms of the sequence. Alright, so we're going to talk about two types of sequences today, arithmetic and geometric. So arithmetic is when the pattern is you're adding or subtracting a fixed amount. Okay, and that's basically what this says. And that fixed amount's called the common difference. Alright, so we're going to find the common difference of these arithmetic sequences, and then write the next three terms. So we're going to list the common difference as the letter D. Okay, so what's happening here? We go from 3 to 7, 7 to 11, 11 to 15. So in this one, we're adding 4. So the D is just 4. So we find the next three terms, so we add 4 to that, so that's 19. Add 4 to that, that's 23. Add 4 to that, that's 27. Alright, the next one, we go from 5, we're going down. Okay, so we know we're subtracting. We're going down to 3, down to 1, so we're subtracting 2 each time. So the D here is negative 2. Okay, a negative 1 minus negative 2 is negative 3. Negative 3 minus 2 is negative 5. Negative 5 minus 2 is negative 7. And ladies and gentlemen, you have just completed your first arithmetic sequences. Okay. Alright. Now, let's go right here. So if we want to find a certain term, let's say the 5th term, or the 6th term, or the 9th term, we're going to use nth to describe it could change. Okay, so the nth term of an arithmetic sequence with the first term being a sub 1 and a common difference of D. You're going to use this formula right here. You're going to take a sub 1, which means the first term, plus the number of the term you want to find. So if you want to find the 9th term, you put a 9 right here. Then whatever the common difference is goes right here, and that will help you calculate what that term is going to be. Okay, so this time we're going to find the 12th term. Okay, so we know that n is 12 of the arithmetic sequence whose first term, so they give us a sub 1, is 2750, and the common difference is 50. So remember, the formula we're using here is a sub 1 plus n minus 1 times d. Okay, so we do 2750 plus 12 minus 1 times d. Okay, so 12 minus 1 is 11. 11 times 50 is 550. 2750 plus 550 is 3300. So that's what the 12th term of that sequence would be. Alright, let's do another. Find the 20th term, so n is 20, of the arithmetic sequence whose first term is 5, and whose common difference is negative 2. Okay, so a sub 1 is 5. 5 plus the 20th term minus 1 times negative 2. Okay, so 20 minus 1 is 19. 19 times negative 2 is negative 38. Negative 38 and 5 is negative 33. So the 20th term would be, and you need to write it a sub 20 like that. And when I say sub, that means subscript of 20. A sub 20 is negative 33. Okay. Alright. Moving right along. Now, suppose that we want to find the sum of the first 20 terms or the first 6 terms or what have you. So if we are finding the sum of the first n terms of an arithmetic sequence, what we're going to have to do is find that term. So it's like a twofold process. You have to find that term and you have to add it to the first term, multiply by how many terms you had, and divide by 2. Okay, so remember here, I'll put a little note here. Remember a sub n is a sub 1 plus n minus 1 times d. Okay, so we have to do that first. Okay, so we're going to find the sum of the first 20 terms. So n is 20. In the arithmetic sequence of 3, so that's our first term, 7, 11, 15. And we found this one earlier that the common difference was 4. So step 1 is we need to find the 20th term. So we're going to take the first term plus 20 minus 1 times 4. So this is 3 plus 19 times 4. So that's 3 plus 76. So a sub 20 is 79. Now we're going to find the sum. So sum of first 20 terms. So we're going to do n, which is 20, times a sub 1, which is 3, plus a sub 20, which is 79, divided by 2. So this is 20 times 82 divided by 2. And that's 1640 divided by 2. So the sum is 820. Okay, so be careful on the sum one. It's a twofold problem. Alright, and so that's everything for arithmetic. So let's do geometric. Alright, so geometric, you're going to multiply instead of add by a fixed amount. And if you're dividing, you're just going to turn that in a fraction. So if you're dividing by 3, you're multiplying by 1/3. If you're dividing by 2, you multiply by 1/2. Okay, so a geometric sequence is a sequence in which each term after the first term is a non-zero constant multiple of the preceding term. The constant by which we're multiplying is called the common ratio. So instead of the common difference, it's the common ratio. Alright, so for the common ratio, we're going to let that be an R. Okay, so find the common ratio. Alright, so looking at this one, it goes from 2 to 6 to 18 to 54. So they're multiplying by 3. So if I multiply the next 3 terms, that'd be 162. 162 times 3 is 486. 486 times 3 is 1458. All right, here, 3 to negative 6 to positive 12 to negative 24. If it's alternating between positive and negatives, you know you're multiplying by a negative number. Because when you multiply negative times a negative, it becomes positive. Then you multiply by a negative, it becomes negative. And here we're multiplying by 2. Okay, so this is going to be 48, negative 96, and 192. Okay, now, if we're trying to find the nth term, so we're trying to find the 20th term or the 15th term or what have you. So this formula is a sub n equals a sub 1 times r to the n minus 1. So this time the n minus 1 is your exponent. Okay, so you're going to need to keep those formulas straight. Okay, so let's do some problems with that. Maybe we can get that paper put up. Alright, so on this one, it says find the nth term of the geometric sequence. So on this one, it says find the 8th term. So n is 8. And then it says whose first term is 5. And the common ratio is 3. So remember the formula is a sub n equals a sub 1 times r to the n minus 1. Okay, so we have 5 times 3 to the 8 minus 1. Okay, 8 minus 1 is 7. You do exponents first. 3 to the 7th power, 2187. 5 times 2187 is 10,935. That would be your 8th term. Okay. B. This time you're finding the 6th term, whose first term is 3, and the common ratio is negative 2. So again, we do 3, because that's the first term, times negative 2. Be careful here because that negative 2 is going to be in parentheses, okay? And then you're going to do 6 minus 1. So this is 3 times negative 2 to the 5th power. Now, when you raise a negative to an odd power, it stays negative. So this is going to be negative 32. 3 times negative 32 is negative 96. And that would be a sub 6. Okay, so that's this one. That's this one. Alright, let's do the last one right here. Find the number of viruses in your body. Okay, so we have an application problem here. After 18 hours, so 18 is your n. If you initially have 1, so a sub 1 is 1, and the virus doubles every hour. So the ratio is 2. Okay, so you have 1 times 2 to the 18 minus 1. This is 1 times 2 to the 17th. And I guess if I wanted to be consistent, I should put this around this. Okay. 2 to the 17th power. I would never give you one like this and not let you use your big calculator for. So that's 131,072 times 1, which would be, you would have 131,072 viruses after 18 hours. Makes you feel good, doesn't it? If you start with 1 and they double every hour. Alright. Comparing arithmetic and geometric growth. Suppose you've won a lottery and you can choose one of the following options. You can receive $20,000 this month, $30,000 next month, $40,000 the following month, and so forth for 30 months. Calculate the total payments. Okay, that's an arithmetic sequence. Okay, so if we want the sum, okay, A sub 1 is 20,000. The D is 10,000. It's increasing by 10,000 each month. And we're doing 30 payments. Okay, so remember, we do step 1, which is to find A sub 30. And to find A sub 30, we do 20,000 plus the 30 minus 1 times 10,000. I about made that an exponent. We're doing arithmetic, not geometric. So that's 20,000 plus 29 times 10,000. So that's 290,000 plus 20,000. So that's going to be 310,000. That's what you're going to get paid on the 30th payment. Okay, so the total you would make, step 2, which is the sum, is you would take the number of payments, take the first plus the last, then divide the whole thing by 2. So that's 30 times 330,000. Just 9,900,000 divided by 2. So that would be 4,950,000 would be your amount. Okay. B, the lottery agency will not give you any money now, but will set aside 1 cent in the account and double it to 2 cents next month. Double it again to 4 cents the following month. Continue doubling it for 30 months and then give you the amount in the account at that time. Calculate the final amount. So this one is a geometric. Okay, this should actually be 0.01. So I'm going to have to calculate this one. $0.01, and the ratio is it doubles, and The number you want is 30. Okay, so what we're going to do here is 0.01 times 2 to the 30 minus 1. So 0.01 times 2 to the 29th power. And that's going to give you 5368709.12. So that will actually give you 5,368,709.12. So if they pay you 1 cent a month the first month and double it every month for 30 months, it's actually a better deal. So they ask you and see which is the better option. And it says before doing calculations. Most people are going to pick A, but choice B gets you an extra roughly $400,000. Okay? Alright, so that one's that. Alright, backside, Fibonacci sequence. Okay, Leonardo Pisa, also known as Fibonacci, wrote a book in which he introduced the Hindu or Arabic numeration system to Europe. His intent was to explain this new system in order to replace a more tedious Roman system of numeration for doing calculations. Alright, so he included in his text the following problem, which has given rise to perhaps the most famous sequence in the history of mathematics. Assume that every pair of baby rabbits will mature during their second month and produce a pair of baby rabbits during their third month. If we place a single pair of adult rabbits in the pen, how many rabbits, both babies and adults, will there be in the pen in the 8th month? We're assuming that once adults start producing babies, they do so every month from then on. So the Fibonacci sequence is the sequence that begins. You start with 1, 1, and then you add those together and get 2. And then you add the number previous to that to get 3. 2, 3 gives you 5. 3, 5 gives you 8. 5, 8 gives you 13. 8, 13 gives you 21, and so on and so forth. Okay? So you could take 1, add the number previous to it, which is nothing, and get 1. For each term after the second is the sum of the previous 2 terms. Okay? So we often label the terms in the Fibonacci sequence by F1, F2, F3, F4, rather than A1, A2, A3, A4. Okay, so the type of problem you would see with this is given 2 terms in the Fibonacci sequence. You must find the specified term. Okay, so let's say that I give you that F7 is 13 and F9 equals 34. Find F8. So if the rule is I would add this to this number to get this number, right? That's the rule. Add the 2 previous to get that one. Then you could take this one and minus this one to find f of 8. So 34 minus 13. So f of 8 would be 21. You could also be given two numbers side by side that, let's say, f of 6 is 10, f of 7 is, no, what is f of 6? 1, 2, 3, 4, 5, 6. Okay. F of 6 is 8. F of 7 is 13. Find me f of 8. And then they're in order, so you would just add 8 and 13. And that's 21. So those would be just random numbers. You wouldn't have the Fibonacci sequence written in front of you. So those would be types of problems. Now, just in case you're interested in how it occurs in nature in so many different ways, like for sunflowers and the different patterns on a pineapple. There's even the golden rectangle and all the things like that. So if you want to read over that, I've included that, but I'm not going to read to you on this video. So if you have any questions, please let me know. I hope you have a great day.